Soil is all around us. It's in our beaches, in our forests, beneath our feet. But have you ever wondered how soil gets its strength?
No, neither have I. But shear strength is actually an interesting topic. Different soils are stronger or weaker in shear, depending on the particles' void ratio, angularity, and gradation, to name a few properties. When you think about it, soil particles are like candy. They come in all different shapes and sizes. In the lab, we can test the soil's shear strength using a triaxial test. Let's go do one!
To prepare the sample, first place the membrane onto the triaxial base. Put filter paper within 2 halves of the mold and situate the halves over the membrane. Place the clamp over the mold and tighten it. Fold the membrane over and connect to a vacuum line at the desired pressure. Here's the final product. Let's go bring this over to Matt.
Now that the apparatus is set up, it's time for the nerds. Bring in the nerds! Not that kind of nerd. Where are the real nerds? Those will do. Now we pour the nerds into the apparatus.
We ran a triaxial test with the nerds, but more on that later.
I'm going to do the same experiment with whoppers. Where are my whoppers? I said, where are my whoppers?
Now let's put it in the device.
Wow, that was a great test. According to my calculations, I think that the nerds should have a higher shear strength because there's less void space, they're more angular, and it's more well graded. Let's take a look at the results.
Keep in mind that the candy in our tests were supposed to represent real soils. The whoppers were comparable to a soil that has smooth, round particles, like Ottawa sand. On the other hand, the nerds most closely represented a soil that is non-uniform in shape or size, such as rock screenings. Here we have the results from an actual triaxial vacuum test performed on both Ottawa sands and rock screenings prepared at low densities. Since the peak of the curve for the rock screening is shown to be higher, it is clear that this soil has the greater shear strength. This next graph shows the effect of relative density on shear strength. When the triaxial tests were performed on the same soils prepared at higher densities, the shear strength of the rock screenings increased, as shown by the higher peak of the curve.